Astronomers made an announcement on Thursday that immediately stirred tremendous interest across the global scientific community. They had detected what they described as the most promising hints yet of possible life on a planet beyond our solar system. While this does not amount to the confirmation of extraterrestrial life, the findings have sparked both excitement and skepticism, fueling a vigorous debate within astronomy and planetary science. The planet at the center of this discussion is K2-18b, a distant world located approximately 124 light-years away in the constellation Leo. For years, researchers have wondered whether K2-18b could be an ocean-covered planet with the right conditions to host microbial life. Until now, the evidence remained inconclusive, but the latest observations made with the powerful James Webb Space Telescope have intensified the intrigue surrounding this peculiar exoplanet. A team of British and American scientists used Webb to examine the chemical composition of K2-18b's atmosphere. During their analysis, they detected signatures of two chemicals, dimethyl sulfide DMS and dimethyl disulfide, which have long been regarded as potential biosignatures. A biosignature is any substance, element, or phenomenon that could indicate the presence of life. On Earth, DMS is produced exclusively by living organisms, primarily microscopic marine algae known as phytoplankton. Because no known geological or non-biological process on our planet produces DMS in significant quantities, the presence of this chemical elsewhere in the universe has often been considered a compelling clue of biological activity. The detection of these molecules on K2-18b therefore immediately raised a provocative question. Could life, even in its simplest microbial form, be thriving on a planet so far away? Despite the excitement, the researchers involved were careful not to overstate their findings. They emphasized that the evidence remains preliminary and that more data is needed before any definitive claims can be made. The signals observed by Webb are not yet strong enough to cross the scientific benchmark known as the 5 sigma threshold, which represents a high level of statistical certainty. In other words, astronomers cannot yet rule out the possibility that the signals are the result of noise, unknown atmospheric chemistry, or some non-biological phenomenon. Nevertheless, the implications remain profound. If confirmed, the presence of these chemicals could reshape humanity's understanding of where life can exist in the cosmos. Nitya Madhusudhan, an astrophysicist at Cambridge University and the lead author of the study published in the astrophysical journal Letters, expressed both optimism and caution. In an interview with BBC News, he said that the team hopes to obtain decisive evidence soon. "This is the strongest evidence, yet there is possibly life out there," he explained. "I can realistically say that we can confirm this signal within 1 to 2 years." Not all experts share Madhusudhan's confidence. Some independent scientists have argued that the findings should be interpreted with considerable skepticism. They point out that earlier studies of K2-18b have already sparked scientific disputes, particularly regarding models of its atmosphere and the interpretation of previous spectral data. Moreover, recent observations within our own solar system have shown that DMS may not be an exclusively biological molecule after all. Last year, astronomers detected traces of DMS on a comet, suggesting that under certain conditions, the compound could form through non-organic processes. This discovery complicates the argument that DMS is a definitive biosignature. However, Madhusudhan and his colleagues argue that the concentration of DMS-like signals observed on K2-18b appears to be thousands of times stronger than anything documented on Earth or on comets. Such unusually high levels, they believe, point more convincingly toward a biological source, although only further scientific investigation will determine whether this theory holds up. K2-18b is a fascinating planet for reasons beyond its atmospheric chemistry. With a mass more than 8 times that of Earth and a radius about 2.5 times larger, it falls into a rare category among the roughly 6,000 exoplanets discovered so far. It orbits within the so-called habitable zone, or the Goldilocks zone, of its host star. This is the region where temperatures are not too hot and not too cold, making it theoretically possible for liquid water to exist on the planet's surface. Liquid water is widely believed to be the most essential ingredient for life as we know it. While being in the habitable zone does not guarantee habitability, it remains a crucial factor in determining a planet's potential for supporting life. Studying such distant worlds is incredibly difficult. Telescopes cannot capture direct images of most exoplanets because they are too far away and too faint compared to their bright host stars. Instead, astronomers rely on a technique called transit spectroscopy. When an exoplanet passes in front of its star, the starlight filters through the planet's atmosphere before reaching our telescopes. Molecules within the atmosphere absorb certain wavelengths of light, leaving behind a chemical fingerprint. By analyzing these fingerprints, scientists can determine which gases are present in the atmosphere. The James Webb Space Telescope, with its highly sensitive instruments, has dramatically improved astronomers' ability to study these faint chemical signatures. In 2023, Webb made a groundbreaking discovery when it detected methane and carbon dioxide in the atmosphere of K2-18b. This marked the first time that such carbon-based molecules, often associated with biological or geological processes, had been observed on an exoplanet located in a habitable zone. The telescope also detected weak hints of DMS during the same investigation, prompting researchers to schedule additional observations using Webb's mid-infrared instrument. This second round of data collection allowed the team to observe the atmosphere across different wavelengths, enhancing their ability to distinguish between various molecular signatures. The new results showed much stronger signs of the chemicals initially detected, although still not strong enough for an indisputable conclusion. Even if the presence of DMS and dimethyl disulfide is eventually confirmed, scientists caution that it would not automatically mean that K2-18b hosts life. There may be exotic, previously unknown chemical processes capable of producing these molecules without biological activity. After all, scientists only recently discovered DMS in cometary material, overturning the long-held belief that it was exclusively produced by Earth-based organisms. The universe is full of chemical pathways that remain poorly understood, especially under extreme conditions, unlike anything found on our planet. However, Madhusudhan argues that the sheer strength of the detected signals on K2-18b makes purely non-biological explanations less likely. In his view, the high concentrations observed could point to large-scale biological activity, potentially in an ocean-rich environment. K2-18b has long been considered the leading candidate for what astronomers call a Hycean planet. The term Hycean refers to worlds that are significantly larger than Earth and shrouded in hydrogen-rich atmospheres, while also being covered in global oceans. Such planets could theoretically maintain stable life-supporting conditions, despite being hotter and more massive than Earth. Many Hycean planets are believed to have atmospheric temperatures reaching up to 200 degrees Celsius, 392 degrees Fahrenheit, far hotter than anything humans could survive. Yet microbial life, particularly heat-resistant extremophiles, could potentially exist under such conditions. The combination of water-rich oceans below and hydrogen-rich atmospheres above makes Hycean planets one of the most promising categories in the search for life in the galaxy. The possibility that K2-18b might be a Hycean world is part of what makes the new findings so compelling. If life exists there, it would suggest that biological processes can thrive in environments vastly different from Earth, expanding the range of planets considered potentially habitable. It would also imply that life in the universe might be far more common than previously imagined, especially since Hycean planets appear to be relatively abundant. Still, confirming the presence of life on K2-18b is an enormous scientific challenge. The planet is located too far away for physical exploration, and even robotic probes cannot reach it with current technology. All evidence must come from remote sensing, careful modeling, and repeated observations. Over the next 1 to 2 years, astronomers plan to continue studying K2-18b with Webb and other future telescopes. Each new dataset will help refine their understanding of the planet's atmospheric composition, surface conditions, and potential habitability. Only after multiple cycles of analysis can scientists hope to reach the level of certainty required to declare that life has been detected beyond Earth. For now, the findings represent a tantalizing possibility, a clue that life might exist elsewhere, but not a confirmation. The scientific community will continue to approach the results with both excitement and caution, knowing that extraordinary claims require extraordinary evidence. Yet the fact that humanity is even capable of detecting chemical traces from a planet 124 light-years away is itself a remarkable testament to modern science. Whether or not K2-18b ultimately proves to harbor life, the search is bringing us closer to answering one of humanity's oldest and most profound questions. Are we alone in the universe?